Hi all, this is Doug Warren, and in this presentation we're going to be examining paired t-tests. Our objectives today are to determine what paired t-tests are and when to use them. We'll look at procedure for paired t-tests, that way you can calculate them on your own without SPSS. But since we all have that program, we will also look at how to run paired t-tests in IBM SPSS. And finally, we will learn how to interpret and analyze the results. So, what are paired t-tests? Well, basically, it's a test to determine the difference between two variables for the same subject. And also, it can be run to determine whether or not the mean difference between two sets of observations is 0. So, that's all well and good, but when do we use paired t-tests? Well, one reason to use it would be to determine if changes have occurred over time. Say, for instance, when the population census comes out next year, you want to see if there have been changes in a particular demographic. You can use a paired t-test to compare that demographic in the 2010 and 2020 censuses. Another reason would be to determine similarities between two like groups. Our textbook gives an example, which we'll look at in a minute, of fathers and mothers' education levels. A paired t-test can tell us whether they are the same or if one group is higher or lower than the other. Another use of the paired t-test would be to make comparisons before and after a factor has been introduced. We'll actually work through an example of this as well, looking at the survival of a fish species before and after water treatment was introduced. If you want to calculate a paired t-test yourself, there are 4 steps. 1. Calculate the sample mean. 2. Calculate the sample standard deviation. 3. Calculate the test statistic. 4. Calculate the probability of observing the test statistic under the null hypothesis by comparing t to a t distribution within, or sample size, -1 degrees of freedom. The value can be found either in the statistical tables or using statistical software. And we all have that statistical software, so we will go over that. But first, let's look at the hypotheses we will either be accepting or rejecting with the paired t-test. First is the null hypothesis, stating that each will equal 0 or no change, both samples are the same. The alternative hypotheses are the two-tailed, the upper-tailed, and the lower-tailed. And here are the equations for each one of those. Now, let's look into SPSS. We'll go with the example in the book, seeing if there's a difference in the education level of fathers and mothers in the study. Now, I know that this question is in our homework for this week, but I don't think I'm giving away any spoilers or answers or anything, because all I'm doing is walking you through the same steps that your textbook told you to. Okay, so first, with the program open and the HSB data file loaded, we'll go to Analyze. From there, Compare Means, and then click on Paired Sample t-Test. Once there, we'll move father's education into variable 1, so highlight father's education, hit the arrow, it should go to variable 1, and repeat the same step for mother's education, moving it into variable 2. Hit OK, and we will get the results in our output. Okay, the first 2 things to generate are not actually part of the paired t, but we need to look at them anyway, and it can compare the means and find information about the correlation. Now, the high correlation does tell us that the parents are highly educated, but it doesn't tell us the significance, and so we're going to need to look into the paired samples test for that. Okay, so looking at the significance, you see the very last box says significance two-tailed. And we see the p-value is 0.019. This rejects the null hypothesis and tells us there is significance. So now let's go back and look at that first table, the means in table 1, and we see that the fathers had the higher education level. Now, let's look at a different way to run paired t-test in SPSS, because it's always good to know more than one way to do something. This time, we are comparing the survival rate of fish before and after treatment was added to the water, because I think any presentation is more fun if you add animals to it, so we're going with fish. This example I got from Virginia Commonwealth University. Okay, so since we don't have the data set for this, we're going to have to enter the values ourselves. And so here are the values for untreated, see it going across, and treated. So we can enter those into SPSS. Now, once we've got those entered, we can select Compute Variable from the Transform menu. There we'll name the target variable diff and create the numeric expression treated minus untreated. After selecting OK, the computed differences will appear in the data window. And we'll want to create a normal QQ plot to assess the normality of the created differences. Because remember, from our textbook, it said that you need normality to run the paired t-test. As with before, we're going to go to Analyze, Compare Means, but this time, instead of going to paired t-test, we're going to one sample t-test. And I know this sounds counterintuitive when we're wanting to get a paired sample t-test, but the fine people at Virginia Commonwealth assured me it will produce a paired sample t-test, and I'm trusting them. Now, select diff, and then click the arrow button to enter it as the test variable. Click the Options button to enter the appropriate confidence level, which is 98%, if it needs to be entered there. Go ahead and click Continue to close out of options, and then you can click OK to get your output. Now let's analyze and report the results. So you can see we compute the differences as treated minus untreated, and we can see the data is approximately normal since the points lie close to the diagonal line in the normal QQ plot, so we know that it was appropriate to run a paired t-test. So we have our hypotheses, the null hypotheses, which is equals 0, or the alternative, which is greater than 0. And here we have our significance at 0.01. Now, since we have paired data and we don't know the population variance of the differences, we will look at our paired t-test. We will reject the null hypothesis if the p-value is less than 0.01. Looking at the output, we see t equals 2.3407 with 7 degrees of freedom. P-value, significant, two-tailed divided by 2 equals 0.0518 divided by 2 equals 0.0259. So we can conclude that since p-value is 0.0259, and that's greater than 0.01 at alpha, we fail to reject the null hypothesis. Interpreting that data, we can say that at the alpha of 0.01 level of significance, there is not enough evidence to conclude that the treatment increased the mean number of surviving fish. Now, if you need to clear up any confusion, any of these links on the reference page provide great resources into looking at paired t-tests, seeing examples, how to use it, how to interpret that data. So if I've left anything that you need to clear up, that's where to go. And thank you for listening and following through this with me. And I appreciate any feedback you can give me. Thanks.